So today we're starting Unit 3, which is functions. And before we start functions, we need to look at basically what a function is and what a relation is. So today we're going to talk about representations of a relation. So we need to talk about some vocabulary. So it says a coordinate plane is formed by the intersection of two number lines, the vertical, so the y-axis, and the horizontal, so the x-axis. So a coordinate plane is just talking about a graph. So the y-axis, the x-axis. It also says a set of ordered pairs is called a relation. A relation can be depicted in many ways, including an equation, a table, a mapping, or a graph. So today we're going to look at how to represent a relation using a table, mapping, or graph. So let's go to the first example. So example 1 says represent the following relation using a table, graph, and mapping. Then state the domain and the range. So it gives us this relation. So a relation is just a set of ordered pairs. And the first thing we're going to do is represent it as a table. So all we do for a table is all the x values go where the x's are, all the y values go where the y's are. So the first ordered pair is 4, 3. Remember, in an ordered pair, it goes x and then y. So my x is 4, my y is 3. So the next ordered pair, my x is -2, my y is -1. The next ordered pair, my x is 2, my y is -4. And then the last ordered pair, my x is 0, my y is -4. So that's a table, just listing the ordered pairs in a table. The next thing is called a mapping. So all the x values go where the input is, all the y values go where the output is. If you have any repeat numbers, you do not write them more than once. So like if you can look at the x's, 4, -2, 2, 0, they're all unique numbers. So I'm going to write them all down. So 4, -2, 2, and 0. The output values, though, see how it's using -4 twice? So I'm only going to write 3, -1, and -4. So I don't write the -4 twice. Then what you do is you draw an arrow from the input to the corresponding output. So since 4, 3 represents an ordered pair, I draw an arrow from the 4 to the 3. -2, -1, so I draw an arrow from the -2 to the -1. 2, -4, so I draw an arrow from the 2 to the -4. And then 0, -4, I draw an arrow from the 0 to the -4. To use a graph to represent the relation, all you're doing is placing points where the ordered pair is. So at 4, 3, 4 is the x, so we go over to 4 on the x-axis. And then since y is 3, we go up 3. And you just make a point. So -2, -1, I go -2 on my x, -1 on my y, and I make a point. 2, -4, I go to 2 on the x, down 4 on the y, and then I make a point. 0, -4, that means I don't go anywhere on the x-axis, but go down 4 on the y-axis. Now then it says to state the domain and the range. The domain are all of the x values. The range is all of the y values. So since my x values are 4, -2, 2, and 0, my domain is 4, -2, 2, 0. My range is all of my y values. Now again, since -4 is repeated twice, I'm only going to write it one time. So my range is 3, -1, or sorry, -4, and -1. So let's look at the next example. So here I have 4, -3, 3, 2, -4, 1, and 0, -3. So again, as a table, I have 4, -3, 3, 2, -4, 1, 0, -3. As a mapping, I have 4, 3, -4, 0. So input is just another word for all of the x values. My output are all of my y values. Again, -3 is written twice over at the table. I only write it once as a mapping. So -3, 2, and 1. Then I draw arrows from the input to its corresponding output. So 4, -3, 3, 2, -4, 1, and 0, -3. And that's my mapping. So then my graph. I go to 4 and down 3 for 4, -3. Make a point. 3, 2, so I go over 3, up 2. -4, 1, I go to the left 4, up 1. And 0, -3, I don't move on my x, but I go down 3 on my y. The domain are all of the x values, so 4, 3, -4, and 0. The range is all of my y values, so -3, 2, 1. Okay, so that is how we represent a relation using a table, mapping, or a graph, and then stating the domain and the range. Another key concept for relations is determining whether we have, or when we are comparing two things, what the independent variable is and what the dependent variable is. So the independent variable is the value of the variable that determines the output. The dependent variable is the value of that is dependent on the value of the independent variable. So I know you guys have probably done this in science before, but the independent variable is our x, and what usually does is it explains the y. So we also call it explanatory. The dependent variable is our y, and that responds. So it's the response variable. So that's another word to kind of help you. So usually the x explains the y. Let's just look at an example. It says in warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. So the independent variable should explain the dependent variable. So I would think that temperature, the temperature outside, is going to explain how much electricity you use. Because think about it, right? We're talking about electricity, heating, air conditioning, right? Bills. So my independent variable would be the daily average temperature. My dependent variable would be the amount of electricity used. Now B says identify the independent variables and dependent variables for the relationship. So the number of calories you burn increases as the number of minutes that you walk increases. So think about this, right? The number of minutes you walk should explain how many calories you burn. So the amount of calories you burn depends on how long you walk. So the independent variable would be the number of minutes you walk. The dependent variable would be the number of calories you burn. So that was 1.6. We're going to actually go on to 1.7 today, just the first page, so page 3. So functions. So in a relation, okay, we can have a function. And a function is basically a relation in which every element of the domain is paired with exactly one element of the range. Now we can use something called the vertical line test to see if a graph represents a function. And we do that if no vertical line can be drawn so that it intersects the graph more than once, then the graph is a function. So I'll explain it more as we go through the examples. So here it gives us tables, mappings, and graphs. So if I want to check to see if each relation is a function, I'm checking to make sure that each input value has only one output value. So see how we have the numbers 1, 3, -5, and 6? If it is a function, all of these will only have one answer, will only have one output. So like 1 goes to 2. That's the only one in my input or in my values of x. So that only has one answer. 3 goes to -4. -5 goes to 2. 6 goes to 9. It's okay that -5 and 1 have the same answer. The only thing that we care about is that each of my inputs only has one answer, one value. So, yes, this is a function. And how I would explain is that one input has only one output. So the input is my x, the output is my y. So one x value has only one y value. So if I look at the mapping, what this is saying is that 3 goes to 5. 3 also goes to 1. So the input here, the input is 3. It has two different answers. It has an answer of 5 and an answer of 1. -2, it's saying, has also two answers. It has an answer of 5 and -3. And then it's saying 6 has one output or one answer. Well, this would mean it's not a function because 3 and -2 have two different outputs. Now, if we look at C and D, the graphs, what we can do for this, instead of just looking at each ordered pair, which I could do, we can do something called the vertical line test. So if I draw a vertical line through each one of these points, if it intersects the point, or if it intersects anything more than once, it's not a function. So like this line only intersected this point once. This, when I draw this line, it only has one intersection point. This only has one intersection point. This only has one intersection point. This only has one intersection point. So this is a function, and our explanation is that it passes the vertical line test. And I'll let you shorten it, the VLT. Now D, this is talking about, this one, obviously it doesn't have points. It's connected, it's a circle. But what I'm looking for is anywhere I draw a vertical line, if it's a function, it should only intersect my relation in one spot. Well, if you notice, anywhere I draw a vertical line, it's hitting my circle in more than one spot. It's hitting it in two spots. So this is not a function. And it's not a function because it does not pass the vertical line test. And again, you could have shortened that to the VLT. Alright, that's all we're going through today. So what you're going to do for the sub, right, you guys, he's going to give you, or she is going to give you your homework packet, and you are doing pages 1, 2, and 3 on your homework packet. I'll see you guys tomorrow.